Hello, everybody.
Hello, sir. How are you?
I'm doing well. Nice to meet you, Mazavin and team.
Hi.
Good to meet you.
Nice to meet you virtually as well.
Yes, yes. Can you see the background? Is it okay?
Yeah, it looks great.
Okay, good.
Thank you.
Thank you for sending this through, Mazavin.
Thank you, sir. So we will start in a minute. So hope by then that time some more people will join.
Yeah,
no
we
problem.
might want to give a pause for a little bit, just to get time for everyone to come in, especially a DT, of course.
Yeah.
Yes.
Of course.
Yeah. I joined a couple of minutes early because I wasn't sure, whether this is the right link or not, to make sure I'm there before the time starts.
That's always best.
Yeah.
Thanks so much for taking your time to present. I'm sure you're very in demand right now. I can imagine you probably have a lot of speaking engagements happening right now.
Yeah, I mean,
yes,
I also
exactly.
saw many media coverage and
yes, it's been pretty busy last few weeks with the media attention, giving interviews, meeting with journalists about the story, and they wanted to always know more, even personal stories and all of that. So I think, yeah, it's been quite overwhelming on top of teaching responsibilities as well, because this is the beginning of the term here in the UK. And I lead a BSc program, Global Humanitarian Studies. So being the program lead as well, it's been quite overwhelming beginning of the fall semester as well. But I'm, always happy to give talk and meet new people. So there you go.
Thank you. Oh, that's the price of success. No, but I was really pleased when I saw the study. I had no idea that was coming out, but I was really excited to see it. It's really good work.
Thank you.
Okay, well, we've got a growing number of people joining by the minute.
yeah.
By the way, can you hear me fine? Is there any sound or echo? Anything?
No, it's all right.
Okay, that's fine. Okay, thank you.
Mahajibin, you spoke with the DT today to double check?
Yeah, she confirmed.
Okay. Then no need to ping her.
Maybe we can start in a minute.
Well, I would just let everybody know that we need a DT to start though, right?
Okay, yeah.
So let me ping her on Skype. She's often on Skype. But she doesn't seem to be there now.
It wasn't somehow on my calendar. I knew it was today, but I thought it was from 7 o'clock. Is it not from 7 o'clock?
7 in Dhaka time.
Okay, 7 in Dhaka time. So are we already late?
Yes, we are a few minutes late. So we should, we're about 10 minutes late.
Oh boy, okay.
I will be
because
light
it just simply wasn't. Oh, okay, right. Okay, let me just download. Yeah.
I think we can also forego the background if it's too difficult.
Yeah. Let's do. I can get my background sorted later. Yeah, don't worry.
Shall we start?
Yeah, I
Yeah.
think so.
Okay. So you're the master of ceremonies, right, Mahajibin?
Yeah, I will briefly tell about Dr. Shams because although he doesn't need an introduction nowadays. Anyway, welcome everyone to TAFSSA first webinar. TAFSSA is transforming agri-food systems in South Asia, a 1 CGIAR regional integrated initiative to support actions that improve equitable access to sustainable healthy diets, improve farmers' livelihoods and resilience, and conserve land, air, and water resources in South Asia. Today is the first webinar of TAFSSA webinar series. Today our speaker is Dr. Mohammad Shamsudduha Shams. He will be presenting his recent research. The title is Bengal Water Machine, Food Security in Bangladesh. Dr. Shams is an associate professor, humanitarian science in the Institute for Risk and Disaster Reduction, IRDR, at University College London, United Kingdom. Dr. Shams is the program lead for a BSc in Global Humanitarian Studies course at UCL. He holds a PhD in hydroecology from UCL, and his geographic interest spans from mega deltas of South and Southern Asia and Sub-Saharan Africa to the entire globe. Now, this is the introduction of a brief introduction for Dr. Shams, but as this is our first webinar, so I would like to request Dr. Timothy Krupnik, the lead for TAFSSA, to tell about our webinar series, objective, and a little bit about TAFSSA. Thank you.
Thank you, Mahajibin, and welcome to everybody who has taken your time to join, especially to those of you who are in Bangladesh joining on a Thursday evening. It shows your dedication and interest. Mahajibin gave a really wonderful introduction, but we are kicking off tonight a seminar series that we hope to hold monthly seminars for issues that relate to agri-food systems, development, and environment in South Asia. As Mahajibin indicated, we are launching this seminar series as part of TAFSSA, which is Transforming Agri-Food Systems in South Asia, which is a CGIAR regional integrated initiative. And what that means is that we have brought together some of the region's most talented, passionate, enthusiastic, smart, innovative researchers and development practitioners who are coming together to work creatively in a transdisciplinary team to try to solve the region's pressing agri-food systems crises and also address the environmental outcomes of the region's agri-food systems. So when we started to plan the seminar series, the idea came to have our colleague Dr. Shams, who has kindly been willing to join us today, and my colleague Aditi Mukherjee will further introduce the seminar series and his work. But we're very pleased to have your attendance, and we're very pleased to have this as our kickoff seminar. We will also keep you in the loop when we have our next seminar, and we will be continuing to try to feature researchers who are very focused on South Asia and or from South Asia with a focus on agri-food systems, environmental issues, and their consequences in South Asia. Thanks very much for joining. Aditi, over to you.
Thank you. Thanks, Tim, and thanks for this opportunity to introduce again my dear colleague, Mohammad Shamsudduha. Shams and I also had the opportunity of working together on our IPCC report, where Shams wrote the groundwater section of the report as a contributing author, and he brought in all the new insights that we have on groundwater and climate change. Very briefly on the Bengal water machine, which Shams will be talking about, it's something that has personally intrigued me for a long time, knowing that working in Eastern Gangetic Plain, where I do in parts of West Bengal, where farmers very much like Bangladesh have been pumping groundwater since the 70s, and they do not report any perceivable drops in groundwater level. They would always, when you talk to them, they would say, but the water levels comes back after monsoon. And that was when early on I had come across this seminal paper published also in Science, like Sham's paper, which was published way back in 1975 by Revel and Lakshmi Narayan, who called this the Ganges water machine, and all of a sudden a lot of it made sense. But then I suppose it has really been lack of the kind of data that you require to test a hypothesis of that kind has been what has been preventing, or lot of us knew this and anecdotally, but I think what Shams and his team have done wonderfully has used rigorous testing of this through fantastic data that Bangladesh collects. And that's it. I will stop here and let us all listen to Shams and his wonderful paper. Thank you so much. And it is also so policy relevant. I hope that we would have an opportunity to discuss about the policy relevance of it, especially in view of climate change. Yes, over to you, Shams.
Thank you very much, Aditi. And thank you, team, and also you, Aditi, for inviting me. And I'm especially delighted and honored to be the first speaker to kickstart this TAFSSA webinar series. So thank you again, Aditi and team, for inviting me. So I'm going to start sharing my screen. Hopefully you can see that. Okay, if you give it thumbs up. Okay,
yes,
good.
We can see it. Yeah.
All righty. So I'll just park it here. And this can go away. Hide floating meeting panel. Yeah. All righty. So yeah, greetings to you all from Brighton, UK, where I live. And again, welcome to this webinar. So I'm going to talk to you about a recent paper that Aditi mentioned, published in Science magazine on the last month, on the Bengal water machine, quantifying freshwater quantified freshwater capture in Bangladesh. I slightly changed the title for this talk because this is as part of the transforming agri-food systems in South Asia. So I try to brought in food security, although by background, I'm a hydrogeologist. I don't have any specialty, if you like, on the food system. But I'll try to make a kind of indirect point how Bangladesh food security has been sustained basically because of the operation of this Bengal water machine. So let's begin the talk. And oops, okay, so those of us who are kind of passionate researcher of groundwater in particular, we are quite delighted that this year has been quite remarkable for the hydrogeology community around the world, because earlier in the year, we celebrated World Water Day with the slogan, groundwater, making the invisible visible. That was also marked by a report published by UN Water. I also contributed to that report, also titled Groundwater Making the Invisible Visible. And then when we got the paper published in Science, that in a way, I think, put groundwater on the front cover of a prestigious journal, Science. So I thought, as a passionate researcher of groundwater, I cannot be more happier this year. And I think groundwater has been really underrepresented in national water policies, not only in Bangladesh, but many other countries around the world. So in a way, this is an effort to make it more visible, and also to start discussion, debates, and also making people, particularly the young students and young researchers, quite aware of these natural resources. So with that, I'm going to start by giving you a kind of a global overview of groundwater withdrawal, where and how much we use. So I often use this map from Yoshi Wada, a colleague of mine, published as part of his PhD work some time ago, showing globally where groundwater is used. And you can see in the kind of colored map, so the blue to red color indicating basically where you have groundwater use around the world. So globally, we use about 1,000 cubic kilometer of groundwater per year, which is about a quarter of the all freshwater withdrawal. So it's still not a lot. There is a potential to use more groundwater, but of course, sustainably. Hopefully, as we are all talking about climate change and particularly climate crisis, we all know climate crisis is basically water crisis in many ways, because it increases the water insecurity. So going forward to address climate crisis as well as climate adaptation, there will be, I think, inevitably more reliant on groundwater going forward. About 70% of the global groundwater is used for agriculture, and the distribution is actually quite, it varies. The distribution is quite high across the world. So for instance, in South Asia, about 50% of land or more land is actually irrigated by groundwater, whereas in sub-Saharan Africa is about 5% or so. And particularly in the context of Bangladesh, about 80% of all irrigation water supply actually comes from Bangladesh. We also use groundwater a lot in Bangladesh. By background, a Bangladeshi, so I'll be referring myself as a Bangladeshi here throughout my talk. So we also use a huge amount of groundwater for drinking water supply. Now, at a glance, what Bangladesh has kind of achieved so far over the last 50 years since its independence. It's a small country. The size, I think, is as big as Tamil Nadu in state of India, and maybe twice the size of, I think, the state of Assam in India. And those of you who are in the UK would know that Bangladesh is as big as England in the UK. So it's a small country with a very densely populated kind of land. Population is about 165 million people. And the economy of this country is growing very rapidly. This is the second largest economy in South Asia. I mentioned about 97% Bangladeshis have access to clean water, and Bangladesh has remarkably achieved near self-sufficiency in food production, which is the topic of my talk today. And the other important sector is the RMG, so the ready-made garment industry sector in Bangladesh, and it's ranked second largest RMG exporter, which is also a sector very heavily dependent on groundwater. A little bit about the kind of water extremes in Bangladesh. We live in a country which is flooded almost every year, and it's normal to have flood every year. I think 25% of the country normally gets flooded every year, and it's good in a way because it brings the flood water brings more soil and nutrients and sediments. That is also quite important for the sustainability of fertility of land in the country. But when it goes above 25%, so for instance, in 1988, I was in high school. I was remember I was fishing from from the kitchen of our house because the water level was so high in 1988. And also in 1999, we had a big flood. So flood is very common, as we know, in Bangladesh, and those of us who are Bangladeshis particularly are familiar with the flood. The other extreme, which we don't hear a lot, is the dry season. Sometimes can be too dry, causing drought situation. So the northwest part of Bangladesh is particularly quite susceptible and vulnerable to drought situation. And you will see later on, this is the very place where the Bengal water machine has been actually working very successfully for many decades. But there are also, currently depletion issues, which I'll be talking to you in a moment. Why is the water extreme in Bangladesh? That's because of the rainfall distribution. It's such that 90% rain falls during the monsoon season. So between May and October, we get about 90% of all of the rainfall happening in Bangladesh. And there is a very kind of sharp contrast and the gradient, if you like, in the rainfall. So the rainfall is highest in the northeastern part of Bangladesh, close to the Indian state of Meghalaya. As many of you know, Cherrapunji, a place in Meghalaya, is the wettest place on earth, receiving about 10,000 millimeters of rainfall. So that part of Bangladesh, the northeast, is very wet in the monsoon season. As you go from the east to the west towards Rajshahi, you will see rainfall decreases, and the annual rainfall can be about 1,500 millimeters a year. So there is a very sharp contrast in the kind of distribution of rainfall falling in the country. And that's, you can see very nicely here, the monthly distribution of rainfall. Monthly average is about 180 millimeters, but average doesn't mean very much when 5 months of the year, nearly 5 months, so November, December, January, February, and March, where the rainfall can be as little as 50 millimeters or less. So it's quite extreme in terms of the seasonal rainfall distribution in Bangladesh. Just to kind of wrap up the overview, so there are 2 points here I would like to make that Bangladesh has achieved so far. Water security in drinking water. So between 1980 and 2015, diarrheal diseases, the mortality associated with waterborne diseases, particularly among the children under 5, has decreased substantially because of the improved drinking water supply. But those of us who live in Bangladesh know very well that there is also arsenic and salinity contamination problem in groundwater, which I will not be talking very much today. It's a subject for another day. The other point I just want to make is that the food security, so dramatic improvement in food production that has transformed the country from worst famines and mass starvation. We saw it in 1943 and then 1974, soon after Bangladesh became an independent country. We had a massive famine and mass starvation that killed nearly 1 million people in the country. So the transformation from that famine-prone country to kind of nearly self-sufficient nation in food grains in the past few decades has been possible because of the abundant groundwater resource. In Bangladesh, groundwater, as I said, used a lot, particularly in the northwestern and north central part, and also northwestern part of the country, primarily during the dry season to produce rice crops. The rice crops in particular that we grow in Bangladesh during the dry season is called the buru rice, which is quite high yielding, but also very kind of water thirsty. It takes about 500 millimeters to about 1,000 millimeters of irrigation to produce buru rice, and it primarily comes from groundwater. So I calculated a few years ago, published in a paper that about 32 cubic kilometer of groundwater is used in Bangladesh per year to produce crops through irrigation and also to provide drinking water supply. In my calculations, I didn't include the industrial water supply. So you can see that it's a lot of water. It's nearly 5 times the total water content in the lake, in the Kaptai Lake, which is the only reservoir we have in Bangladesh, which is used to produce electricity. But in terms of the global use of groundwater, is not a lot. But again, this amount is is much more compared to many developed countries such as the UK, where 2.2 cubic kilometer of groundwater is used every year. So it's an order of magnitude greater in Bangladesh, the amount of groundwater used compared to the UK. Now come to the paper again. So why and how Bangladesh has been sustaining the groundwater use for so long. And the answer is the operation of a water machine that we call the Bengal water machine. So the paper was published in Science last month. So I would like to acknowledge my authors, Richard Taylor, Izazul Haq, Sarah Noreen, Anwar Zahid, and Kazimuddin Ahmed from Bangladesh, who all contributed to the paper. And the concept, basically the idea of testing and quantifying freshwater capture actually came during my PhD work with Richard Taylor in UCL Geography back in 2007 and 2011 when I finished. So during that time, the idea came to us to test the operation of this water machine and to quantify it. So it's been a long journey coming, and even longer because the original idea, as Aditi mentioned, came from a paper, a special issue published in Science called the Ganges Water Machine by Roger Revel and Venkatacharya Lakshminarayana, the two visionary scientists, really proposed this groundbreaking idea back in 1975. And this is the very place where they kind of developed their conceptual model, the Ganges River and the Ganges floodplain, where it floods every year like Bangladesh, where also population density is one of the highest in the world. And people use too much, people use groundwater to produce rice crops, particularly I think rice, dry season rice they used in this very part of the land in India. So this is where they developed their conceptual idea, and they said basically, if farmers keep pumping along the river Ganges, during the dry season, they will lower the water table, and then during the monsoon season, the water table will go up and refilling the aquifer. And if they do it for a few years, incrementally increasing dry season pumping, then at some point a new equilibrium will be reached where the overall groundwater recharge will be enhanced and induced through this process. And this is what they call the Ganges water machine. But as Aditi mentioned, that there wasn't any kind of take up of this very idea nearly 50 years ago, and it was kind of forgotten because there was no real initiative either by the Bangladesh government or Indian government. So in our Bengal water machine paper, why do you call it first Bengal water machine? Well, because we have observed there are certain variations that in the kind of recharge pathways that we observed between what was described by Roger Revel and Venkatacharya Lakshminarayana and what we observed in Bangladesh. So you can see here a few kind of figures showing different kind of pathways of groundwater recharge. So the groundwater is recharged through infiltration of rainfall. So it's the diffuse recharge process. Groundwater recharge in Bangladesh also takes place through return flow from the irrigation and also from different surface water bodies such as lakes and rivers, and also some incised river channels, particularly seen in the Bahrain Tract region, the northwestern part of Bangladesh. So the process is quite diverse, and because of that, we are calling it a Bengal water machine because it's slightly different from what was described originally by Roger Revel and Venkatacharya Lakshminarayana in their Ganges water machine paper. So those of you who maybe are struggling a little bit to understand how come pumping groundwater can actually increase the storage rather than depleting the storage, I had to recently respond to a lawyer who was puzzled by our paper and didn't really understand how groundwater pumping can actually lead to more storage rather than depleting the storage. So I had to develop over the last few weeks some very simplistic figures for audience. Those of you who may not come from groundwater science may understand it better. So it's very simplistic figures that I'm showing here. So you can see the two figures, A and B, on the left-hand side, representing a situation in the pre-development period. So like pre-80s would be the kind of pre-development period in Bangladesh where there wasn't much groundwater use, versus the two figures C and D on the right-hand side, top and bottom, representing a developed period, so post 1980 period. And you can see that in the dry season, the top two panels representing dry season situation, where you can see that the groundwater level is a bit higher than the river level, basically feeding into the river channel during the dry season, whereas the situation reversed in the developed period where groundwater is no longer feeding to the river, rather it's draining also water from the river. And you can also see the irrigation pump is pumping groundwater, creating a cone of depression around the well during the dry season. And then during the wet season, which is the bottom right-hand side figure, showing that the aquifer level is basically going up again because of recharge coming from not only diffuse recharge from the rainfall, but also from indirectly from river channels and other surface water bodies. And you can also see there is, in the middle of the figure, there is groundwater level monitoring well. So if you look at the groundwater level monitoring well data, hypothetically, you can see here that over time, that the oscillation of up and down, the dry and wet groundwater level has actually gone up. So it increased, the water table fluctuation, if you like, has increased over the years, suggesting that the aquifer is being is replenishing after the lowering of the dry season water table because of pumping during the dry season, and then recovering it, going almost to the full condition in many places. And then by doing that process, it has increased the more kind of recharge during the monsoon season. And this is what we call increased capture of fresh water induced by groundwater fed pumping in Bangladesh. So this is in a kind of nutshell explaining what is meant by the Bengal water machine or even the Ganges water machine. So actually this finding is not new. Some of my early works from my PhD that I published, so the one that I published paper in Hydrogeology Journal already shows that from the long-term hydrograph, long-term groundwater level monitoring data, you can clearly see that the hydrograph A and B clearly showing an increased seasonality. So the dry season is getting lower, deeper and deeper, and the wet season is almost going up to the pre-development stage, suggesting an increase in groundwater recharge and increase in groundwater storage. But then there are other areas in the country, such as Dhaka city, which is dependent pretty much on groundwater supply, where groundwater is being pumped pretty much unsustainably over the last few decades to provide drinking water supply to nearly 20 million people living in Dhaka city, and also to meet industrial demand in the city. Where the aquifers, the groundwater levels are actually going down and down every year, and doesn't really get the sufficient recharge or the time to recover fully. So we are seeing reduced seasonality and declining trend in some parts of the country. So with that idea, you can see that so the picture here I'm showing is from the Hydrogeology Journal paper. So that's basically shows 2 years on the same hydrograph, one from 1974, so the pre-development stage, and then the hydrograph for 1 year, 2006, which is showing the developed condition. You can clearly see that the dry season water level has decreased several meters, but then the wet season water level is nearly rising up to the pre-development stage. And this additional storage space in the aquifer is created because of heavy pumping. You can also notice that the recharge period has actually substantially extended from like 4 months in the pre-development condition to about 7 months in the post-development or the current development stage. But overall, the aquifer storage has increased. So this is all not new. It was all published in Hydrogeology Journal paper. But what we didn't do at that time is basically to quantify it at the national scale. This is what was done in the science paper. And we are particularly grateful to Bangladesh Water Development Board, the government agency who is in charge of monitoring Bangladesh's groundwater resources. They have more than 1,200 groundwater level monitoring stations around the country. They're mostly shallow, so the median depth is about 30 meters below ground, and groundwater level is measured every week. Manually in almost all places, but recently they have started monitoring using automatic device across the country. So we are very, very blessed, if you like, with the enormous amount of data that is out there, and thanks to Bangladesh Water Development Board again for providing us with the data so that we could test the operation of the Bengal water machine and also quantify it. Now, not all the data here you can see are of very good quality. There are lots of issues in the data set, such as missing gaps, and particular borehole boreholes were replaced occasionally. From dug wells to piezometers, piezometer 1 to piezometer 2, because over time, because of corrosion in the borehole pipe, when it was in the 80s and 90s, it was mainly iron cast iron, so it was corroded, so they were replaced by PVC later on. So we went through all of that check, and we identified about 465 boreholes that are of kind of sufficient time period. So the median period is about 43 years, and then the missing gap in the data is about 7%. So we use those data to quantify the operation of the Bengal water machine. I'm quite mindful of time, so I'm going to rush through very quickly towards the end by showing you a series of boreholes representing the operation of the Ganges Bengal water machine. So here, one hydrograph from Kumilla showing the increase in seasonality over time, but then it's also showing depletion in both dry and wet season. But this actually, even though it's showing declining trend, but that doesn't actually mean that the actual groundwater storage is depleting in this place. Groundwater storage has actually increased, but the water level happens to be quite low in the recent times, suggesting that the time that is required to recover is not there. Series of other hydrographs here. You can see this is from Jamalpur, this is from Mymensingh. Dramatic shift in the kind of dry season water levels. This is from Rajshahi, this is from Pabna, this is from Kushtia, this is from Jashore. So we have seen all over the country the operation of the Bengal water machine in different kind of shallow aquifer systems across the country. So we have identified 153 of the 465 borehole records that we looked at. So about 35% of the borehole is actually showing operation of the Bengal water machine. The remaining of the remaining boreholes, about 25% showing some kind of depletion, and about 40% showing some kind of stable or unchanged kind of signature in the groundwater level. Now, how we actually estimated, quantified the capture of the fresh water through this operation of the water machine. Here, I'm showing here that a particular borehole you can see, and we identified the pre-development period as is marked here on the top diagram. and also the post-development dry season levels. And we calculated recharge for every single year by using the water table fluctuation method. And you can see that the recharge over the years in this place has increased from about 88 millimeters in the pre-development recharge to about 185 millimeters in the developed period. And we then subtracted the for every single year the excess recharge from the pre-development stage, and we summed up all of the accumulation of increased recharge, and this is what we call the cumulative freshwater capture at each site of all 153 sites where we observed the operation of the Bengal water machine. And then we mapped it using various geostatistical technique to report the overall capture of fresh water. And we have seen the overall volumetric capture of fresh water between 1988 and 2018 is about 75 to 90 cubic kilometer of fresh water, which is 12 times more than the reservoir capacity in the Kaptai Lake in Bangladesh. In the interest of time, I'm going to finish in like less than 5 minutes. So just to show you that the change in groundwater recharge between pre-development and then development period, you can clearly see that the areas in the northwestern part of Bangladesh, which is now known as the kind of breadbasket, if you like, of Bangladesh, was very, very dry, famine prone kind of area of Bangladesh. As you can see, the rainfall is very low compared to the rest of the country. And this is the very region where there was only one crop per year, and that was dependent heavily on the seasonal monsoon rainfall. Now, the very dry area, very kind of drought-prone region of the country has received the highest amount of kind of freshwater capture, and you can clearly see that in the change in recharge between the pre-development and development period. So this is a figure from the paper, just to show you that the groundwater recharge, which is shown in figure A, panel A, is comparable with to the groundwater pumping, so groundwater abstraction used for dry season rice cultivation. So they kind of follow the similar pattern, suggesting that over the years, groundwater pumping has increased, and so has groundwater recharge. Now, it's not all good news. As I mentioned, there are areas around the country where groundwater depletion is taking place, particularly in Dhaka, around Dhaka city. Groundwater depletion has been taking place over the last 10-20 years, where Bengal water machine is probably working, but the amount of water that is abstracted, that is withdrawn from the aquifer, is probably an order of magnitude from compared to the recharge that is taking place there. Therefore, that negative balance is driving the water level going down every year. Similarly, in some parts of Rajshahi, particularly the high Barind area, where geology is very similar to Dhaka city, where we also observed groundwater depletion taking place in the backdrop of the operation of Bengal water machine. But when you have too much water taken away from the aquifer, but comparatively the recharge is less, or the time that is required to fully replenish is not there, then you would inevitably lead to depletion. And this is what we are observing in some parts of Bangladesh. And also we are saying it's not gonna happen in all over the country. It's not gonna continue, because in the western part of the country, where we have seen the successful operation of the Bengal water machine, are also the places where it is reaching to the limit, the maximum limit of the kind of potential recharge, where by increasing more pumping, we will be depleting more groundwater rather than increasing more recharge. So we have to be quite mindful about the specifics of this operation of the machine and the constraints that is there in order to recognize where we can perhaps enhance it, and where we need to really be careful and perhaps stop more pumping going forward. Very quickly, I'll finish. So the point here is that Bangladesh has achieved food security over the years because of the abundance of groundwater and also the operation of the Bengal water machine over the years. And the Buru rice is currently contributing to 54% of the overall rice production in Bangladesh, which is pretty much entirely dependent on groundwater. Now, I think this is a topic that Aditi is very interested in, is the energy that is required, right, to pump water. So in Bangladesh, about 80% of the irrigation wells are powered by diesel. 20%, about 20% is powered by electricity. There is a very tiny fraction of the wells that are currently powered by solar. So we need to enhance more solar power going forward to make this operation of the Bengal water machine also kind of environmentally sustainable. And just to finish off, is it happening only in Bangladesh or maybe in some part of India? Well, we haven't looked at in other places, but we think in similar kind of geology where there is seasonal humid region and groundwater is very shallow and groundwater pumping is taking place, surface geology is permeable, favorable for more enhanced recharge, are also the places where perhaps we can look into to see the operation of this water machine. So I'm going to finish here and stop and get back to you, team and Aditi. Thank you very much for listening.
Thank you, Dr. Shams. Considering the time constraint, we are not going to allow all the people, but we have a couple of questions. So how we can proceed with these questions? Shall I read it out one by one, or?
I think that's
yeah.
Yes, sorry
Yeah.
for going over the time. I can see there are lots of questions in the chat box. Whether I should be able to answer to all. Can we maybe group some of the questions, and perhaps I can respond to a group of questions rather than individual questions? Apologies for again going over the time.
Yeah.
No worries. Yeah.
The one question is from Hiranath. He's asking if we use the groundwater more, then the capacity of aquifer will be increased or not?
It's a good question. Again, as I said, the Bengal water machine is not working everywhere. It depends on a number of factors. First of all, the surface and subsurface geology needs to be favorable for enhanced groundwater recharge. There has to be pumping, and there has to be plenty of water during the monsoon season. So when all these things combinedly work in a kind of harmony, this is when you can see enhanced groundwater recharge. So the places like the Bareen tract and the Dhaka city, where we have Madhupur tract, are the two areas where you have very thick clay layer on top of the aquifer, where infiltration capacity is of the top clay layer is very small, where increasing more pumping might lead to depletion over time. Are there other questions? I can see Aditi, you have your hand raised.
Yes, I think there are other questions, and we should answer them, but very quickly, and you can answer it at the very end, is Bangladesh now has a new law that requires every new well to be registered, which was something that was abolished in 1988. So how will your study, can your study help Bangladesh government do those in a bit better way, so that it's not a blanket kind of a rule? It does it where BWM works, and it doesn't do it, where BWM works. So that was my question, but I'll stop here.
Okay. No, I think to answer your question very briefly, we are going to work with different agencies in Bangladesh. We will start our work with Bangladesh Water Development Board because we have a co-author and colleague there on the paper. Through him, we will approach to other related agencies, particularly Bangladesh BADC, Agricultural Development Corporation, to see actually where do we need to impose the restrictions and where we perhaps can relax some of these restrictions. But again, it has to be very kind of location specific, and it has to be done very carefully with a lot of monitoring. Yeah, I can see a hand raised, Dr. Sattar Mandal.
I was going to suggest that we perhaps take a question from Dr. Mandal and also work in Dr. Wais Kabir's question. Dr. Mandal's a celebrated expert on water and all things policy and agriculture related in Bangladesh. And Dr. Wais Kabir had a question in the chat. Dr. Wais Kabir is the former executive chairman of the Bangladesh Agricultural Research Council, BARC, and he asked, how do you signal the government for stopping groundwater development in the Barind Tract? And perhaps, Dr. Mandal, you might also want to add a few points to that, and we can listen to the response there.
Hey, thank you very much indeed. I'm very humbled to hear your very kind words about me. I'm not. I know very little about groundwater, but whenever I speak about groundwater irrigation, water market in Bangladesh, I always feel like showing my profound respect to my great mentor, late Professor M.R. Biswas, who was a great hydrologist and irrigation engineer, who brought me down from the classroom to the rice fields really in the late 80s to understand what was happening in this irrigation water market. So Professor Shamsudduha, I congratulate you and your team on your very successful completion of this study. And I think this is not the end. You will continue doing more really. My submission is like this, that I agree with you that this is just a confirmation of the earlier work, and then it confirms the nature-based solution within quote and unquote you said. I agree with that, and that is about the availability of water at large, that it can be available from the groundwater if we manage it properly. But my point is that this availability or utilization of groundwater for irrigation in a rice-based farming system like that depends on not only this nature-based solution, but largely on the socio-economic solution really. That is the matter which Aditi also speaks about and then works on in many, many different ways really. In other words, that how much of this groundwater that we can make available or can be utilized very properly, appropriately and efficiently. And here lies the question of irrigation water market. Our modest studies from the late 80s throughout 90s and then later on showed that irrigation water market in a smallholder situation has been somewhat competitive and reasonably accessible to small farmers through a myriad of contractual system you have. But then Aditi brings, and the Tushar Shah also brings this water and power nexus in groundwater irrigation, which is coming up again. And Aditi and some of our colleagues at BAU are now looking at this thing in the context of Bangladesh. I like this word really, our terminology, Bengal water machine. first class. But then crucial variable to me is that how much profitable will be the rice production in this country, or how much profitable it will continue to remain, will dictate whether or not groundwater abstraction through this private sector-led groundwater irrigation water market will be a success. The second point is diversification. Now, the policy in Bangladesh is to diversify from rice to non-rice crops, which has begun in many, many different ways, particularly conversion of rice land to orchard. You have known that, particularly in the north. Then the question comes then, if you withdraw lesser amount of water because you have diversity from rice to non-rice, that it means that there will be lesser recharge to the aquifer. You don't need because it's full already, meaning that there will be some level of potential underutilization of groundwater, which could be tapped from the nature. I do not know the answer, but then do you see as a scientist a loss or gain or what? But that brings us to this question of greater policies, that Bangladesh policy now says that reduce water or use of groundwater and increase use of surface water as much as you can really. Now, and West Kabir mentions ban on deep tube wells in the buried areas, and probably indirectly shallow tube wells. I would like to hear your voice. How rational will that be? You have partly answered that it should be location specific, I know, but then if you combine it with the energy, water energy nexus, then we would like to hear more of your comments on this. I think I stop here really. And then
Thank you very much, Dr. Mondal, for your very insightful comments, and you are speaking from your experience, which is really, really appreciated. Yeah, I think you have brought a few key points. So particularly the point about diversity in crop types, and you also talked about the water market. How do you manage the private sector water market? And also you mentioned about the current policy, government Bangladesh policy, to perhaps reduce more groundwater use in the marine track in particular. And I think these are all very valid points that need a very careful discussion and debate, especially in the light of what we have reported in this science report, the Bengal water machine, is that we are not saying that something is going to happen in future. What we have reported in the paper, that what Bangladeshi farmers were able to do in the last few decades, when they started pumping in the 80s and early 90s through now, and where in Bangladesh we were able to achieve more groundwater storage and more groundwater recharge through the successful operation of the Bengal water machine. But equally, we have also identified areas where this machine has failed. It has not sustained beyond a certain point because of the facts that I also already mentioned about the geology, the surface and subsurface geology in particular, and the operation of the pumping, and then the available water to recharge the depleted aquifer. So these things, I think, need to be looked at very carefully, because at the moment the policy is basically around the notion of depletion of groundwater levels. That doesn't really take into consideration of the groundwater storage that has increased in many places. When we see groundwater level is falling, the notion is that it means groundwater depletion is taking place. We don't consider that the depletion of groundwater level doesn't actually mean that change in storage space, which we have observed through our paper. So I think this is, as you said, this is the beginning, and we really need to look with the look beyond and work with the policymakers to see what best we can take out from this finding, from this discovery, but at the same time minding that groundwater is a renewable resource, and it's something that is very precious that we have to protect going forward, as we don't know how climate change is going to impact the operation of the Bengal water machine. We have to be quite mindful and not not basically spreading the news that pumping is good, therefore you go and pump everywhere. So this is something we also try to kind of balance out in the paper by highlighting the limitations as well. I'm quite mindful of time. I mean, there is a lot to discuss, but I'm happy to maybe answer to some of the questions. I know we have gone over the time, but I'm happy to be here sitting to answer some of your questions.
Yeah, Tim, can I take half a minute really to add to this? I'll not do justice really if I do not mention the name and the work of my longtime partner, Dr. Richard Palmer Jones of University of, we started from Oxford and then we ended up with East Anglia.
East Anglia, yeah.
Yeah, East Anglia. He and myself really worked on this field. But one thing I would like to mention what came out of our work is that it's not only the availability question which you have rightly answered to, you call nature-based solution. But the other thing is the micro level understanding of the irrigation command area really, the topography, the soil type, are so much of influential factor to dictate that how much of this groundwater will be extracted by the potential investors or the pump owners depends on this micro variation in the soil and topography and then agronomy of that really. So that's my final point. Thank you.
Thank you for your added comments. Yeah.
We will run this webinar 5 minutes more because we started late and because of the discussion, interactive discussion. We have one more question from M.A. Karim, Chief Engineer, BADC. So his question is like, how much groundwater abstract from shallow aquifer and deep aquifer separately?
Yeah, that's a good question. We, in this paper, we looked at monitoring data only from the shallow system. So we have, as I said, the Bangladesh Water Development Board monitoring wells are quite shallow, and the median depth of the 465 monitoring boreholes we looked at is about 30 meters. So we are only talking about what is happening at the very top shallow groundwater systems. We know deep groundwater is used in Bangladesh primarily in the coastal area, where shallow groundwater is very saline, salty. So deep groundwater is used for drinking water purposes, where we haven't looked at the operation of this water machine. And I doubt that groundwater enhancement is taking place as at that deep, where in coastal water is sourced for drinking water. So we are talking about a few hundred meters below ground level. And at that stage, it is very unlikely for this water machine to operate.
Thank you. You can see Dr. Royce Kobe's hand raised. So your mic is open.
Can I add here? Can you hear me?
Yeah, we can hear you.
Okay. There were some follow-ups of the Bengal water machine publication in Nature, that Bangladesh is quite comfortable in the media. So this is something disturbs me while getting this kind of message to the policymakers that now we are comfortable in abstracting groundwater, irrespective of the geological formation. That's one point that we need to be careful while talking about this Bengal water machine and comfortable groundwater abstraction in the country as a whole. That's one point. Another point is we had a fear during last 2 decades that groundwater cannot be abstracted. As a result, it's not only BADC but also Marine Development Board or Authority. They stopped groundwater development further in this country. So I think the study should give a rational message to the policymakers, particularly government, which part of the country should be having restriction and which part of because we have a blanket rule during 2017 and 18 that restricted groundwater abstraction. And remember, that's only for public water groundwater abstraction. But for the private sector, when you don't need electricity connection, you can have it. So the domestic water or any other individual can abstract water through submersible pump. But whenever you need abstraction through electricity, you need to have REB connection. As a result, you need licensing. So I think we need to be more focused to signal the government what should be the recharge well and the uh, mm, and the non-recharge well to be abstracted in which part of the country. That's what I wanted to take into account, please.
Thank you very much, Dr. Weiss Kovir. Yes, you're right that just yesterday a Nature comment was published by a group of scientists consisting of also Bangladeshi scholars working in NASA in the US, and they mentioned about that the looming water crisis in Bangladesh. That's what the title of the paper. And I don't want to get into too much detail of that comment. I'm still reading it. But what struck me is that they used one particular borehole from the Marine Track region and saying this is the situation happening in the whole of Bangladesh, which could be a misrepresentation of what is happening in the country. And this is exactly the point what we wanted to highlight in our science paper. As I said, it has been a long journey. I spent 10 years of my life working very, very carefully on this concept and going through the data that I collected from the Bangladesh Water Development Board for many years, very carefully looking through the data so that I don't represent the whole country in a way that is actually can be quite what's the word? It's not quite representative of the situation on the ground. So you are right to say that we shouldn't be generalizing things, because hydrogeology, those of us who know about the hydrogeology of Bangladesh can appreciate how complex it is. So oversimplification and generalization of groundwater situation without really appreciating the hydrogeology can lead to negative consequences through policies that are probably not very favorable for sustaining food production in Bangladesh. So I think we have to be quite careful going forward. The population of the country is only going to increase, and climate change is going to add a lot more pressure on the food system in Bangladesh. So, we have to be very careful about the blanket policy of not allowing any groundwater abstraction whatsoever, where we know for sure from this data set that we presented in the paper that many parts of the country where depletion is actually not taking place, more recharge is possible because of the operation of this water machine. So we have to be very, very selective. So we have to keep our monitoring going. We have to really pay careful attention and perhaps devise policies that are very location specific rather than blanket policies that may hamper food production going forward in Bangladesh.
Thank you. With one last question, we were going to end this Q&A. So that is, Shreya has asked this question a few minutes back. Is there any impact of soil type of efficacy of BWM? For instance, is there thick clay soil layers, the recharge levels can significantly constant and surface water storage may be more effective?
Yeah, it's a good question. As I said, the operation of the water machine depends very much on the surface geology. If you have permeable surface geology, meaning you have sand and clay, sand and silt, not clay, then the infiltration from rainwater and floodwater can actually enhance groundwater recharge. But we know that a large part of Bareen tract and also Madhupur tract and also in the coastal area, the surface geology is not that favorable. So it's mainly clay dominant surface geology where it takes a lot of time for groundwater to infiltrate and recharge. So if you pump more groundwater, then you are not really allowing the aquifer to recover because it takes longer time to recharge. We will not enhance the recharge, rather you would inevitably deplete the aquifer. So these are the areas where we have to be very, very careful.
Thank you so much, Dr. Shams. It was a great session. I would like to ask Aditi and team to conclude this session, and we are already late, so a few more minutes for conclusion. Thank you.
Thank you.
Yeah, no, I will keep myself very brief because my laptop is also about to die. I want to say that perhaps Sam's, what is very clear to me from your paper, and I also wrote a perspective piece on the same, is the immense policy value of this, because it's true that Bangladesh, lots of parts of Bangladesh has groundwater concerns, but there are also lots of parts of Bangladesh where it's not a concern. But the kind of law that has been brought, like every small farmer will need a permit before they can electrify their pump. And we have seen that. I have studied that in West Bengal. All it ends up doing is additional rent seeking, additional corruption. It just slows down and makes the lives of small farmers harder. So what we are doing in India is like we are using these kind of groundwater data to see which is a overexploited zone, where it is safe to exploit. So if your work can be done similarly to, demarcate those zones, and then the regulations are accordingly. You don't do the same regulation everywhere, but where it's safe to pump, it should be easy for farmers to pump, and where it's not safe to pump, there should be requirements of permits. But the current policy of blanket permits, I think, would really translate into hardships for farmers practically, which is what we are seeing with the study that we are doing with Professor Mandal and his group. So I think that is, to me, the greatest policy finding from your study, that this can be really applied in a policy relevant way. So, and thank you so much again. And thanks for alerting me to the Nature paper. I'll read that up. Yeah. Thanks a lot.
And I will conclude also very briefly by saying thank you again, Dr. Shams, for your presentation and giving so much time and additional time, and the stimulating and interesting conversation that we have all had this evening, this afternoon, depending on where in the world you are calling in from. I think that the last part of this discussion in many ways has been really what's most important, and it also summarizes in many ways some of the key things that the Transforming Agri-Food Systems in South Asia, or TAFSSA Regional Integrated Initiative, is trying to do. We want to bring evidence to bear to inform policies on management of the environment and management of agri-food systems that do not place blanket solutions into place, but instead use evidence and information and data, well analyzed, well quantified, and well communicated, to try to better inform development pathways going forward. So I want to thank again everybody for joining and listening, and Dr. Shams for your time, and Dr. Kabir and Dr. Mandal also for your insightful comments as well. And once again, this is the first of what we hope to do as monthly seminars. So we will continue to communicate when the next seminar will be held, and we hope to see you then. Thank you once again, everybody.
Yes. Thank you very much, team,
Thank
and
you.
Aditi.
Thank you very much.
Thank you.
Thank you very much. Okay. Thanks for having me.
Bye.
Bye everyone.
Thank you. Bye.